So in this video, we're going to be looking at the osteichthyes, or the bony fish. We're going to look at how they are currently reclassified. We're going to be looking at both freshwater and saltwater fish, and we're going to be looking at the various adaptations that we see within the fish and the environment or the niche that they're involved in. There's over 20,000 different species of bony fish. They have a bony skeleton. We're going to be looking at both ray fin fish and lobe fin fish. We're going to be looking at how they collect oxygen, what levels of oxygen are needed for the fish to do well. We're going to be looking at their circulatory system, their adaptations, how do you determine the sex of the fish. So just a wide variety of information we're going to be covering on this video. So osteichthyes, which means bony fish, has recently been reclassified, and so the class osteichthyes has now been dissolved and has been renamed into two classes. The class Actinopteges, which are ray fin bony fish. This is what we think of when we think of fish. And then we have the class Sarcopteges, which are the lobe fin fish. The example we have here is the coelacanth and the lungfish. And so you got the lungfish on the bottom left, and you've got the coelacanth on the bottom right. And we spoke about the coelacanth back when we did our chapter on evolution. This was a fish they believed was the intermediate between fish and amphibians, the fish that crawled onto the land and became an amphibian, and yet we found that these fish can only live in the deepest depths of the ocean, and if you bring them up too close to the surface, they can't handle that pressure exchange and they die. So how do the fish determine the depth of water that they're in? Well, they have a structure called a swim bladder, and it's a gas-filled sac. And it uses that pressure by regulating it, and it causes it to have a buoyancy. And it can be single chambered, and we see that with trout. It can be three chambered, we see that with codfish, or it can be not present at all, and we see that with tuna. So on the bottom left you can see the trout, on the middle you'll see the codfish, and on the right you'll see the tuna. In addition to buoyancy, it helps to amplify sound for better hearing. And one of the things that I want you to see as we go through the animal kingdom is we as humans we don't invent things. We observe what God created in nature, and we steal it and we modify it. We modify it for our own selfish needs or whatever we feel that we need. But when we look at the swim bladder and the buoyancy and the taking in or the releasing gas to determine depth, does that sound like a submarine? Yeah, because they work the same way. And so over and over again, you're going to see that God created these designs first. We noticed them, we took them, and then we modified them to use them. So when we look at the gills of a fish, they have a covering over them that protects them, and that gill covering is called an operculum. That's a test question. When we look at the heart, it's a two-chambered heart, one atria, one ventricle. Test question. So what kind of fish do you think that is on the bottom? Catfish. Got it? Alright, so when we actually look at a catfish with the little whiskers, the whiskers there actually help with taste. So those are like for taste buds. You also will see those on the external parts of the skin and on the lips and on some parts of the fins. And what do we have here? We've got a true eel as a member of the fish order. And so what is the difference between a true eel and, say, an electric eel? Well, let's look at some of that. Well, for a fish to be in the eel order, they have a dorsal fin that's continuous. It goes on the back. It goes from the caudal to the anal fin. They have very small embedded scales, or they don't have scales at all. They're slippery. So you've heard of slippery as an eel. Okay, so when we look at why are they slippery, they have a slime coat. And so when we talk about the green moray eel, It has a yellow slime that this goes over its body. The body's blue, and so blue body, yellow slime gives it that green color. They also have very sharp teeth. Now right here, when we have a close-up on the right, we have the garden eel. They live in groups where each individual has its own little burrow. Only the head and the front half of the body is usually visible. They're going to be found in the Indo-Pacific area, in warm parts of the Caribbean. So the name relates to how you have huge colonies of these eel-looking structures, and they just sway in the current. It's roughly about 40 centimeters long, has very large eyes compared to the body. It has a weak sense of smell because it has little tiny noses, little nostrils. If it feels threatened, it's going to go back into the burrow very quickly. It has a mucus plug that it can plug up so that predators cannot dig into that opening and get to it. It has a gland in its tail that secretes kind of a sticky substance that helps to keep it burrowed underneath the soil. So if you look at those large eyes and that little tiny nose, it uses its eyes mainly for identifying its food. It is a carnivore. It eats plankton, and it uses those eyes to find the food again by catching that plankton, and then it stays in that burrow, and it just kind of sways its head back and forth to catch the plankton. During its mating season, it'll move closer to the other eels until they're just within reaching distance of them. And then the male will pick the female that he wants to mate with, and he flirts with her by biting at her head and her eyes. But those are the garden eels, and they're actually just gorgeous little creatures. And here's just some of that information that I just told you about the garden eel. They live in groups, but they each have their own burrow. Only the head and front half of the body sticks out. It's found in the warm waters, the Caribbeans, the Indo-Pacific Ocean. And again, it sways with the current, using those eyes, very poor sense of smell, catches the plankton in the water. So what are some differences between electric eels and true eels? The electric eel is a freshwater fish, lays its eggs in the freshwater. True eels are more marine fish. They're going to be in the salt water. They will definitely spawn in the ocean. Electrical eels do not have teeth. They do not have a dorsal fin or a fin on its back. They are also air breathers. In any kind of warm, oxygen-poor water, breathing is going to be difficult if they were to breathe in the water, so they actually have to come to the surface to get their air. If they're not able to reach the surface of the water in order to go above that, then they're going to drown. We can look at the fins of fish, and we can tell a lot by looking at the fins of fish. Now, if we were to compare the little fish on the bottom left, which is called a clown goby, to the little blue fish on the bottom right, which is a blue chromis, look at their tails. Now, you're going to notice that the tail here is more of a rounded or square shaped, where here we have the V-shaped. Now, that V shape that we see there is going to be for fast swimming, for being able to move and dart through the water. Where when we have a rounded or a square-shaped fin, this is going to show a fish that's slow-moving, typically going to be a bottom dweller. Well, how about the nervous system of a fish? When we look at the nervous system of the fish, they're going to have some lines that you would look at. You'd see those on the outside sides of the fish. Those are called the lateral lines. They have an extremely low-frequency vibration. They're able to sense motion, and so they can determine motion of nearby fish. They can determine motion of, if you were to toss out a fishing lure. They can also detect very weak electrical fields. Catfish and sharks can do that. And then some fish, like electric eels, can produce their own electricity. So how do we determine the sex of the fish? Well, it's really going to vary from species to species, and sometimes it's impossible to tell. Some fish are born as males. Now, if we look at our beautiful clownfish over here, all of our clownfish are born as males. And then when you have a grouping of clownfish, look for the largest fish. The largest clownfish is the dominant fish, and that's the female. And then she will have her mated male. If she dies, the mated male will begin to grow. He will convert over to a female, and then the next dominant fish will become his or her mated male. So all of our clownfish are males, except the largest one in the group, and that's the female. On the other hand, when we look at our royal gourami over here, all of these fish are born females. And if you have a grouping of the royal gourami, then the largest fish, the most dominant fish, will be the male. And if it dies, the next dominant fish will change sex to become the male. However, on other fish you have boys and girls, and you don't have that changing of sexes. So platies and mollies, and this is a platy here, you can tell by looking. The male has a little structure right there called the Gonopodium. Now that's going to be important for you to know for the test question. That's how you can tell a little boy fish. And then you'll notice over here that the girl does not have that. So on live-bearing fish, like platies and mollies, the male has the Gonopodium, the female does not. So we have freshwater fish and we have saltwater fish. What's the difference between fresh and saltwater fish? Well, in general, your freshwater fish are going to be more hardy. Freshwater fish, if you think about all the different sizes of lakes and ponds and streams, the temperatures can change, the turbidity can change. It can have a little bit of salt in it, maybe not any at all. It can have different minerals in it. So freshwater fish have to be able to adjust to a wide variety of pH and temperature and minerals being present, where marine fish are in very large oceans. And because the ocean's so large, the temperature doesn't change much. So your marine fish typically do well, best at around 78 degrees. They prefer a pH of around 8.3. They prefer a salinity of 1.22. Everything has to be extremely stable for them. So you have to have a very constant environment for saltwater fish. Freshwater fish, it's a lot more adaptable to the conditions. If you ever want to have an aquarium, it's always best to start and learn with your freshwater fish and then move up to your saltwater after you've had some experience. So if you've ever been in a swimming pool for a very long period of time, you notice you have to jump out and run and pee. Freshwater fish are kind of like that too. They pee a lot. They release large amounts of urine. They don't have to drink a lot of water. They absorb the water in their body through osmosis. And because they absorb so much, they got to let it out. Now saltwater fish, on the other hand, because of the salt content, they're going to have to drink roughly 1% of their body weight every hour or they could dehydrate. Think about that for a second. Did you ever think a fish would dehydrate in water? Yet because of the salt content, the fish could. So a saltwater fish has to drink 1% of its body weight every hour or it could dehydrate. Freshwater fish really don't drink water. They can absorb that through their skin and then they pee a lot. Now this is a platy, and I just wanted to just show you God's sense of humor, just how beautiful the animals are. Do you know what we call this one right here? We call this a Mickey Mouse platy. Look right there. And no, that's not stamped on there, that's natural. So you've heard of the betta fish, and I'm sure when you've heard of betta fish, you've thought of, oh, let's put the betta fish in front of a mirror and let it see it try to fight itself. We know we can't put two betta fish together. Well, the betta fish come from Asia, And from those rice paddy areas of Asia, a lot of times you're going to find these betta fish living in little tiny, um, almost like mud puddles. And it's muddy, and there's not water, a lot of water present. There's not air moving that water, so there's not much oxygen. And so these fish are adapted, having structures called labyrinth organs, which allow them to breathe air. If your betta fish cannot reach the surface, they will drown. And I put some different pictures of some various, this is a Rami down here, and this is a betta fish here. They're absolutely beautiful fish, but again, because they originated from areas with very poor water quality, they had to adapt, and they had labyrinth organs that allow them to breathe air. And this is a picture of a couple of kissing gouramis. This is from one of my fish tanks back in the day. No, they're not being sweet kissing each other. These also have to breathe air or they'll die. But they're showing dominance. They're trying to show which one is the boss. So the question is, how much oxygen do the fish need? Well, the fish use 20% of their energy just to breathe. That's not swimming, that's not hunting food, that's not eating, that's just to breathe. And when we talk about the oxygen in the water, when we think of aquariums and we see those beautiful little bubble makers, you know what we use those for? Nope, it's not to get oxygen in the water. It's actually just to make it look pretty. What you have to do is, if you look at the surface of your aquarium, the water surface has to move. And so that water surface moving is what's pulling oxygen from the air down into the tank. Now, how would that happen in nature? Think of an ocean. What do we have? Waves. The waves moving, we don't see the ocean being completely still. At any place you look at the ocean, you're seeing the water move. And it's that movement that's pulling the oxygen from the air down into the water. Same thing with our lakes and our streams. So when we see a body of water that's stagnant and there's no water movement, we say it's stagnant because there's nothing living there. You can't get oxygen. And when we talk about the amount of oxygen that's in the water, we call that DO, or dissolved oxygen. And that's telling us how many milligrams per liter we have, or what percent saturation is the water, how much oxygen is present. So fish that live in warm waters need a minimum of 5 milligrams per liter of dissolved oxygen. Cold water fish need 6 milligrams per liter of dissolved oxygen. If they're spawning, it's going to need to go higher because they're using more energy. So, we would say closer to 7 milligrams. When you get less than 2 milligrams per liter of dissolved oxygen, that's going to be stagnant. That's not going to support any kind of aquatic life. Again, I just love to show you the beauty of God's fish. Now, these little guys right here are called clown loaches. And they can get quite big. They make a clicking sound. And these little guys, why are they clowns besides looking like clowns? Well, let me tell you, many a person who has had an aquarium has run to their tank thinking they've had a dead fish, because these little guys like to lay on their side and play possum. So you will go over there thinking you have a dead fish, touch it, and all of a sudden he jumps up and starts swimming around. These right here are different loach fish. They're bottom-dwelling fish. This one right here, that is an engineered goby. That is just a cool little saltwater fish. These are all freshwater fish. This guy, he looks like a poisonous type of fish when he's little. And then when he gets larger, you're going to see some of those stripes disappear, and he's going to look more eel-like. However, he is a fish. Students always ask me, do fish sleep? Well, that's kind of a tough question to answer. Let's just kind of go through some. Some fish like to rest on the bottom and may go into kind of a stage that's kind of a sleep stage. Um, Other fish will continue to swim, and so you can see that if you have an aquarium, watch at night, go down there and look, you'll see them swimming back and forth. And what they do is they would turn off one side of the brain, let it rest. The other side is keeping the fish moving, it's keeping water going over the gills. And then after it rests, it will shut that side of the brain down, open up the other to continue to move. Now, I had a clownfish in my saltwater tank, and that little guy would go into a deep sleep. You could go down there and you could actually touch him when he was asleep, and then he would jump up, get mad at you, and bite your hand. But you could touch him because he was in such a deep sleep. So most of the fish will spend some kind of energy saving state that we can call rest. It may not be the equivalent of what we think of as sleep. Some are a little bit more of a sleeper type fish. Parrotfish are like that. My my clownfish in my saltwater tank was like that. And then others will go into kind of like a don't want to say zombie state, but kind of a doze state where they're moving, but they're not really aware of what's going on. It just keeps them moving so that they can keep oxygen moving over, but they only have one part of their brain active. And I just kind of did a little bit more right here with you. Told you that bass and perch rest under logs at night, go into kind of a sleep state. The coral reef fish can be active at day, but hide in crevices at night. Again, my clownfish would fit in that area. So they all have a rest type state.